A 12 kV potential held across a 1 mm ceramic gap. Continuous service at 1200 degrees Celsius. 40 years of switchgear operation without dielectric breakdown or polymer aging. The custom machined alumina insulator carries the entire isolation load. Keyway tabs locking the rotational orientation, stepped flange registering the mounting plane, surface precision controlling the creepage path. Polymer cannot hold this duty. Porcelain cannot machine this geometry. Alumina does both. 4 property axes anchor the engineering case for custom alumina insulators in high voltage duty. Mechanical strength. Flexural above 350 megapascals, compressive strength reaching 2000 megapascals, Vickers hardness around 1800. The strength margin that survives clamping load, vibration, and decades of thermal cycling without geometric drift. Chemical inertness. The alumina matrix resists acids, alkalis, and solvents across pH 1 through 14, with no metal iron contamination during long-term exposure. The corrosion immunity that polymer insulators cannot match in industrial atmospheres. Thermal capability. Continuous service to 1730 degrees in the 99.7% grade, thermal expansion coefficient between 6 and 8 millionths per Kelvin, stable geometry across rapid heating and cooling. And electrical performance. Dielectric strength above 12 kV per millimeter, insulation stability to 1200 degrees Celsius, continuous exposure, low electrical loss, and zero conductive iron migration to compromise long-term isolation. 4 purity grades cover the full alumina insulator duty spectrum, each tuned to a different isolation environment. The 96% grade is the cost-balanced choice for general electrical insulation. Stable dielectric performance with proven manufacturability for high-volume switchgear and motor isolation parts. The 99% grade lifts the dielectric strength margin and the thermal ceiling. The route for higher voltage standoffs and converter equipment where temperature and field stress combine. The 99.5% grade brings semiconductor equipment cleanliness. Used where particle generation and outgassing must stay below cleanroom thresholds. And the 99.7% grade delivers ultra-clean alumina with continuous service to 1730 degrees, fracture toughness, dimensional stability after repeated thermal cycling. And the lowest impurity profile available. The grade for the most demanding power electronics and analytical instrument insulation work. All 4 grades share the same alpha phase aluminum oxide matrix, the same controlled sintering process, and the same insulator-grade dielectric profile. Alumina insulator parts cover the dimensional range from microscale precision insulators to large structural standoff geometries. Standard tolerances hold within plus or minus 0.05 to 0.2 mm depending on geometry. Beyond standard formats, 5 customization pads shape the insulator to the drawing. First, special dimensions. Extra large or extra small diameters, non-standard thicknesses, and ultra-long or ultra-short axial lengths to match equipment-specific mounting envelopes. Second, precision tolerance. Higher grade dimensional accuracy and concentricity control beyond the standard, the precision needed for tight fit assemblies and aligned creepage pads. Third, complex shapes. Integrated flanges, machined steps, threaded features, drilled holes, axial grooves, and the keyway and anti-rotation geometries that lock the insulator's orientation under vibration and thermal cycling. Fourth, special purity. Matrix composition adjusted across the 96 to 99.7% range to match the dielectric, thermal, or cleanliness demand of the application. And fifth, surface finish. Ground or polished surfaces to achieve roughness below 0.4 micrometries, the finish quality that controls creepage tracking and dielectric breakdown initiation. Inside a high-voltage switchgear cabinet, the custom alumina insulator sits between live conductor and grounded chassis. The structural standoff that holds the voltage gap, locks the mounting orientation, and survives decades of switching transients without aging. 5 engineering features make alumina the right material for this duty. Dielectric strength above 12 kV per millimeter. The headline insulation specification, the field stress margin that supports compact 800 volt to multi-kilovolt assemblies without breakdown. Stable insulation to 1200 Celsius degree. Where polymer insulators degrade and porcelain cracks under thermal cycling, alumina holds dielectric performance across continuous high-temperature service. Zero conductive ion migration. The alumina matrix contains no mobile ions that could form conductive pads over time, the long-term reliability foundation for 40-plus year switchgear duty. No polymer aging. Polymer insulators lose dielectric strength through UV exposure, ozone attack, and partial discharge erosion. Alumina holds its dielectric profile indefinitely. Custom rotation locked geometry. Integrated keyway tabs, stepped flanges, threaded mounting features, and precision machined creepage pads, the geometric precision that polymer molding and porcelain firing cannot achieve. Across switchgear cabinets, converter assemblies, power distribution panels, and sensor isolation mounts, alumina insulator parts hold the voltage gap where every alternative material runs out of margin. Ultimately, the alumina matrix delivers what no polymer, no porcelain, and no glass insulator can match: permanent dielectric isolation with custom machined precision across the full equipment service life.